So all we have completed insert first, insert after. Okay. Today, as we will complete this single linked list. The first one is what? Delete. Suppose the first code is a delete first. The sixth option directly I am writing that system.out.println. Println is a delete first. Is a delete first. Is the one. So we are writing the code for this. Else if directly we are calling that method is a delete first. And here it is the sixth option become the seventh option. And we are writing that method static void delete first. So whenever we are going to delete first, we are checking that if it is empty or not. The first one. If it is empty, we can't delete. No? So directly we can say that if root value equals to null. If root value equals to null, directly we can say that list is empty. List is empty, we can't delete. So the root variable is directly available. That's why we are checking directly in all the methods. Suppose if root is not null, if already nodes are there, then we need to write the code for deletion. See, look at this. How can we write the code for deletion? Delete first only, na? Remaining, I'll just. Suppose the nodes are like this. Here it is that values are, I'm giving like this. 8, 5, 6, 7, and is pointing to this. Suppose the 4 nodes are there. First of all, let me delete that first node. Whenever you are deleting the first node, it has to point into the second node. Sir, suppose if second node is not there, the link will be null. You just keep that in your mind. So first of all, keep this root into one temp variable. Temp is equal to 4586. First of all, you should make temp is pointing to this root node. Is nothing but first node that we are going to delete. So taking that node variable, temp equals to root. So the first node address 4586 will be stored into this temp variable that we are going to delete actually. That we are going to delete. And now in this one, root has to pointing to the next node. Na? Suppose if you are deleting the first node, imagine it should point into the second node. So root has to point into root to link. Root has to point into root to link. So into the root to link value should store. Root to link is what? 8785. So in this place 8785 will store. 8785 will store. That is okay now. So it stop pointing to this one. Remember. And next one is very important. Still temp is first node is pointing to the second node. We need to remove this connection also. Sir, how can we remove this connection? It's very simple. Here just you need to place null value. Just null value you have to place. Nothing but temp to link, because not root to link, because root is already pointing to second node. Only temp to link should be null. Temp to link should be null. That's all. That's all. Just giving the message is removed. But one point is first node deleted. So one point you should remember, sir, how memory will be destroyed. Whenever this method execution completed, automatically local variable will be deleted. Temp variable will be deleted. When temp is not pointing to any memory, that memory very soon will be garbage collected. Very soon that will be deleted. So if the object has no left side connection and no right side connection, that will be destroyed automatically by the garbage collection concept. No need to take care of this one. So simply we can say that first node is deleted. Now let me execute the code and check is executing or not. First of all, choice 1, I keep on inserting 10, 20, 30, 40, 50. I'm just displaying that 10, 20, 30, 40, 50. 6, I'm giving delete first. First node deleted. Now let me check 20, 30, 40, 50. Again delete first. Again I'm checking that display 30, 40, 50. Okay, exit. This is delete first. Next one is delete after. Okay. Next one, next concept is a delete after. Delete after. Sir, after a specified node, I want to delete. For that, I am writing. Here it is the seventh option. Seventh one, delete after. I am writing. So exit become 8. Only the location you have to share. That is important. Else if choice is equals to 7, delete after. But what is that location? Calling that delete after the specified node. That location you have to share. Sir, where is the location? You just ask, enter location or enter the node value. This location equals to sc dot next int of, and that location we are passing as an input. So we need to write the code. We need to write the code. Static void delete after whatever the location they specified. Whatever the location they specified, that is. So first we need to check the location is present or not, because what they have given is a valid location or not. For that, first we are calling the length. See, suppose here, three nodes are there. 1 means 2 will be deleted. 2 means 3 will be deleted. 3 means 4 will be deleted. 4 they cannot give because fifth one is not there. So maximum, if length is 4, only 3 they can give. Only 3. Length minus 1. So if that location is greater than or equal to 1 and the location is less than or equal to length minus 1. 4 means 4 minus 1. 3 is okay. It is allowed. Else directly we are giving invalid location. Error, invalid location given. That's all. Just giving the message like this. No, suppose if they have given the valid location only. Just given the valid location. Then first of all, you have to move to that location. See, consider location is 2. With 2, I'll explain so that you will get clarity. If location equals to 2, location equals to 2 is anyway, first you need to start temp. Start with the root. 4586. Sir, how you will move? How you will move? Taking that int I is equal to 1. You know that while I less than location, I less than location, and node temp is equal to starting with the root. If I is less than or equal to location, temp is equal to temp to link I plus plus. So what will happen? First temp value equals to root. Okay, 4586. But location 2 na? See I value 1. 1 is less than 2. Yes, condition is true. Temp equal to temp to link. So in place of 4586, 8785 will store. This one is nothing but is pointing to this one. Okay, is reached na? Location reached. Next I plus plus. I value become 2. Look at the condition. 2 is less than 2, condition false. So while loop terminated because already we reached the location. But sir, actually we need to delete this one. This is the target. So temp to link is the target. Temp to link is the target. Remember that one. Here, node, the target what you are going to delete, that is actually called temp to link. Temp to link. This is the target. Target equals to 6359 is a target. Now, very simple story. Very simple story. Temp is pointing to that. Temp should pointing. Whenever you delete the target, it should pointing to this one. Just observe this. Just observe this. Is pointing to this one. Is nothing but what? 8567. What is 8567? 6359 link. What is 6359? Is a target. Target to link 8567. Target to link 8567. 8567 should store here. Should store here. Is nothing but what is that? What is this one? Temp to link. Is a temp to link will be stored into temp to link. So automatically this will be destroyed. This will be destroyed. Left side link is destroyed. But what I told, suppose if you want to destroy this, it should not pointing to another one also. It's very simple. Target to link, you just make it null. You just make it null. That's all. Target to link, you just make it null. Sir, suppose if they get given 3, now if you want to delete this one, if you want to delete this one, now you are deleting this one. Observe this. If you are deleting this one, it's very simple. What value will be stored? This null value. Target to link null value will be stored here. Yes, correct only. Because you are deleting the last node. Okay. Next one is a target to link is a null. Is a target na? Target to link is a null. Of course, is already null, but once again we are placing null value. So it is applicable to last node also. No need to make any changes in this code. That's all. Simple. So this is delete after. Is delete after. Now we are executing the code. Executing the code. First we keep on entering 10, 20, 30, 40, 50. I just want to delete a 40. So third node I am giving. Delete after 7, is a 3 I am giving. So we didn't give any message, that's why it is not showing anything. Now I'm going to display 2. See 10, 20, 30, 40 deleted. 40 deleted. That's all. Just one message you need to add, node deleted. Node deleted. That is. Next one is just swap the information. Just a swap. Ask 2 locations. Any 2 locations they give. Suppose if they give 2 and 4, take 2 pointer variables. One is make pointing to the first one is pointing to the second one. Just first one pointing to 8785. Second one is pointing to 8567. 8567. That's all. Then using the temp variable, just data swapping. Just data swapping. Sir, how to make the pointers pointing to those locations? First of all, you should take everybody, you should take 2 pointers as well as 2 locations. You ask them, and very important one, first location should be within the range of length, and the second one also should be within the range of length. It should not be 0 and it should not be 5, because only 4 nodes are there. They can give 2 locations between 1 to 4 only. First you have to check. Then one pointer make pointing to first node and one pointer pointing to second node. Then swapping. Here, just adding them. System.out.println swap node data. That's all. Is a 9th option. It will become 9, and if choice is equals to 8, system.out.println enter valid locations to swap. That is, so 2 locations we are taking. Let's say location 1 sa.nextInt, let's say location 2 is sc.nextInt, and then we are just calling the swap function and passing that location 1 and location 2 as inputs. So we are writing the code for that one. Static void swap, taking 2 locations, location 1 and location 2. And first what we have to check? The first one, we need to find the length of the list. Now we are checking if location 1 should be greater than or equal to 1, and same location 1 should be less than or equal to length, and location 2 also same story. Location 2 greater than or equal to 1, location 2 is less than or equal to length, then valid locations given. Else simply we can say that it's invalid locations to swap. That's all. So if they are valid locations, take the variables. Suppose I equal to 1, comma j equal to 1, or same variable you can use, no problem. Quickly I am writing. When I is less than location 1, and 2 variables you have to take node type. One is a p, next one is a q, both starting with the root. And this one also you can write I equal to j equal to 1. Multiple assignment, simple way. So simply we are writing p is equal to p to link I plus plus. So p is make it pointing to the first location. That will complete. Then while this will start, j is less than location 2. Same concept only. So that's why I'm not explaining. Q equal to q2 link j plus plus. I just make p pointing to location 1, q pointing to location 2. That's all. Then finally what we are doing, make the pointers pointing to first location and second location. Here it is a simply temp equal to one temp variable p2 data into p2 data store q2 data into q2 data store temp. Simply data swapped successfully. That's all. This is the code you have to write. It's very simple. First, we are taking two locations to swap the node data. Here we are checking the two locations are within the range of nodes length or not. If the two locations are valid, then take two pointers with the help of two locations. First pointer make the pointing to first location. Second pointer make pointing to second location. Then swapping the data of both locations and giving the message. That's all. So when you are executing this, PQ equal to root. Why not allowed? Okay. Oh, okay. Actually, like this, it is allowed. No? Not like that. No time. I equal to 1, J equal to 1, P equal to root, Q equal to root. Q equal to root. When you are executing the code, suppose 1, 10, 20, 30, 40, 50, 60. Displaying the data. 10, 20, 30, 40, 50, 60. Suppose second node and the fifth node I want to swap. 8. Enter two valid locations. Second, fifth. Data swapped successfully. So that again we are writing the code. Checking 2. Look at this. 10, 20, 50 become 50, 20. Okay. That is. So this is all about a single linked list. Everyone please complete this today. I'll share that. I'll share the video in 2 minutes. Everyone please complete this. Tomorrow I'll explain stack using single linked list, queue using single linked list, and double linked list introduction I'll give, so that the complete double linked list program you have to write. Remember that. So today everyone complete this.